To solve this log equation, we do need to get this log all by itself. We have a few other things over here that are not part of the log. We have log of 5x, but we do need to get rid of the 4 and the subtract 3. So going through and doing our usual solving, we would move the 4 over first. That's a positive 4, so I'm going to subtract 4 on both sides. That's going to give me a negative 3. Log of 5x is equal to 12. Log still isn't by itself. We have a number in front, and it's negative 3 times that value. So I'm going to divide both sides by negative 3. That would give me log of 5x is equal to a negative 4. Now I have our log all by itself. Now I can go through that process called exponentiation. I'm going to make each of these become the exponent. I have to pick a base, and the base has to match the base of the log. There's no number written in there, so we know this is log base 10. So I'm going to write each side as 10 raised to a power. So we end up with 10 of log base 10. Again, there's an invisible 10 there with that log. The base of this log is 10, so those would all match. So we would end up with 5x over on the left side of our equal sign. And then here we have 10 to the negative 4th power. If you evaluate 10 to the negative 4th power, that is the decimal, 0.001. So you could leave it as 10 to the negative 4th or write it as the decimal, whichever you're more comfortable with. And then in our last step, to get the x by itself, we would need to divide both sides by 5. So if you do that, you end up with, for the decimal here, you end up with 0.0002. I take that back. I need one more 0 in there. So here is our possible answer. Otherwise, if you had divided both sides by 5 too, that is the same as 10 to the negative 4th over 5, but the decimal's a better way for us to write that. We do want to go through and check and see if that is actually a solution. So I'm going to plug that back into the original up here. So we would have 4 minus 3 times log of 5 times 0.00002, and I want to see if that's equal to 16 or not. This is log base 10, and I have a log base 10 button on my calculator, so I can just type that in how that is. So if I'm typing that in my calculator, I'm going to do 4 minus 3. You could put multiplication in there, but you wouldn't have to. Just use the regular log button. 5 times 0.00002. I would type it in just like that on my calculator, and if you evaluate that, it does give us an answer of 16. So we end up with 16 equals 16, which is a true statement, and our solution for this does end up being this value of 0.00002. So on these problems, first step is going to be to isolate the log. You have to get the log all by itself first. So if there's anything on the left side of the equal sign with your log, you need to move that over to the other side using our usual solving techniques. Once you get the log by itself, then you exponentiate, and then you should be able to evaluate and come up with your final answer on that. And on each one of these problems, you do need to check your work. As part of this exponentiation process, you can end up with extraneous solutions. So we have to plug those numbers back in at the end before we know if they're actually solutions or not.